Hi all, welcome back to my YouTube channel. In my earlier videos, we had discussed the probability, general probability, normal probability, and discrete random variable, as well as by using discrete random variable, we have covered what the binomial distribution is. Those are really important topics for your ICE, IB, and the other international examinations. Now, in this video, I am going to discuss the continuous random variable. Earlier, we had discussed what the discrete random variable is. Now, what the continuous random variable. Let's see what it is. Continuous random variable. What is continuous random variable? If we consider a discrete random variable takes values you can count. For example, if I toss a coin 3 times and if we define the random variable as the number of heads as capital X, X can be either 0, 1, 2 or 3. But nothing in between. We can't say 0.5 or 1.5 or 2 point something. However, a continuous random variable can take any value within an interval is generally a measured the quantity rather than content. Actually, a continuous probability function, also called as the probability density function, describes the distribution of continuous random variable. If I draw the continuous probability density function, I'll take it as f of x. We'll think the shape of the graph is, this is x, this is f of x, this is f of x. The graph of the probability density function is a curve rather than discrete points. The graph is a curve rather than the discrete points. For all continuous probability density functions greater than or equal to 0, for all values of x, that means if it is defined from negative infinity to positive infinity, the domain negative infinity to positive infinity fx dx is equal to 1. We know that this is the total probability of that particular event. If we want to find the probability in between a given interval, we have to integrate the function within that limit, such as the probability x takes the interval AB is equal to the area under the graph y x is equal to A to x is equal to B. If I draw the graph f of x, this is f of x, it is defined A to B. If we want to find the area under the curve, we know that A to B fx dx. Actually, what is this? This is the probability x is greater than or equal to A and x is less than or equal to B. That's the area under the curve. However, continuous random variable, if x is the continuous random variable and simple x is a particular point in the given interval, the probability when x is equal to simple x is not equal to f of x. Therefore, the probability of x taking any exact value is 0. We know that A to A fx dx is 0. in this continuous random variable, we can't find the probability at a point. If we want to find the probability, we have to consider an interval. Now we will consider some examples. The example 1. A continuous random variable capital X has the probability density function such as f of x is given k times x minus 3 square, where x is in between 0 to 3. Otherwise it is 0. If I draw the graph, zero and then x, this is 3, then it is 0 again. We are asked to find the value of k. K is an unknown. We know that the total probability of this given function, continuous function, negative infinity to positive infinity, f of x dx is equal to 1. However, negative infinity to 0 f of x dx, 0 to 3 f of x dx, plus 3 to infinity f of x dx. We know this is equal to 0. This side also equal to 0. 0 to 3. F of x can be written as k times x minus 3 square dx is equal to 1. K can be taken out. 0 to 3. X minus 3 square dx is equal to 1. This can be written as k times x minus 3 to the power of 3 over 3. 0 to 3 is equal to 1. Now we have to substitute the upper limit. K times upper limit 3 means it is 0. 0 divided by 3 minus lower limit negative 3 to the power of 3 over 3 is equal to 1. We know that k times 27 over 3 is equal to 1. Therefore, k is equal to 1 over 9. We have considered the total probability is equal to 1 to calculate the unknown k. Okay, now we can write the function f of x is 1 over 9 x minus 3 square, where x is in between 0 to 3. Otherwise it is 0. The second part of the question, hence find the probability x is greater than or equal to 1 and x is less than or equal to 2. That means we know that the graph of the function, the graph is, this is 3. We are asked to find the probability from x is equal to 1 to 2. That means we have to integrate the function 1 to 2, 1 over 9 x minus 3 to the power of 2 dx. This is the probability. 1 over 9 x minus 3 square over 3, 1 to 2. This is 1 over 27. You have to substitute the upper limit. Upper limit is negative 1 to the power of 3, negative 1 over 3, lower limit plus 8 over 3. 1 over 27, 7 over 3. Therefore, the answer is 7 over 81. Therefore, the required probability is 7 over 81. In the next video, we are moving the really exciting stuff. Finding the mean, median, and the standard deviation of continuous random variable. If this helped you, subscribe and share with your friends. Thanks for watching my video. See you in the next one. Thank you.